Good day, everyone. My name is Destiny Mabert, and our project is assessing the capabilities of battery technology here at Prairie University.
My name is Luis Saruzi.
My name is Rabiul and our graduate, our advisor is Suzabin Jahed, and we're going to give the credit to Yusuf, who is a graduate student.
Project goals. The main goal of the project is to have a battery that will serve as an energy storage for solar power. To determine the characteristics of 3 different batteries: lithium-ion, lead acid, and nickel cadmium acid battery. Design a circuit using Arduino and obtain the charging and discharging voltage of lead acid, lithium-ion, nickel cadmium batteries. Okay, the introduction. Batteries are electrochemical cells, a container consisting of one or more cells which chemical energy is converted into electricity, and that energy, which is what provides a source of power. There's 2 types of batteries. The primary battery, which is non-rechargeable. An example would be zinc carbon, silver and mercury oxide, and alkaline. The secondary will be rechargeable, which are the ones we're using: lithium-ion, lead acid, and nickel cadmium battery. Over here, you can see this was our first experiment. We were going to discharge a Duracell lead acid battery, which had 20 ampere per hour with 12 volts, using 252 watts loads of resistors in series. And after a while doing this charging, you can see there the graph shows that it dropped beyond the 50%, which was it's 10.5 volts. If you drop beyond that, you can risk to destroy the battery.
After we discharged the battery, we decided to charge it. To charge our battery outside the electrical engineering building, we used the solar panel, inverter, as well as a charge controller. As shown from the graph, we realized that the battery was charging too quickly, and only an hour or 2.5 hours, the battery was already charged back up to 12 volts, so we decided to change the charging and discharging method. Here we are with the different lithium-ion battery as well as the lead acid battery. We decided to use a 12-volt AGM battery instead of the Duracell battery, as well as a 24-watt light bulb to discharge the battery. After an hour, we noticed that once again it dropped past the end of discharge voltage of 10.5 volts. So we decided to immediately stop discharging so that we won't risk damaging the battery. This is where we get into the Arduino code. We decided to monitor it with the Arduino instead of doing it manually. So we used the light bulb. One thing we noticed was that the light bulb was not turning on instead to discharge the battery. So to fix that problem, we debugged the code and added a relay instead of the 2 transistors, because one, the relay is fast, is a simpler code, as well as it less power, and since we are using a BJT and a MOSFET transistors, they're not matching transistors, so therefore they're not working the way they should and giving us the output that we wanted.
Okay, over here on the first picture, you can see we had the first relay, which the charger and the load was going to normally close and normally open, and then we decided to add a second relay. So in this case, we could create a 20-second charge setting point for battery voltage between the charging and the discharging. So in this case, one relay will act, both relays will do the normally open for charging and discharging. Over here, you can see that this is our Arduino source code on the left. In the middle, we have the discharging, and on the right, we have the charging. Okay, over here is a list of our components. This is a circuit diagram of the working prototype. We have the 2 relays there, the 2 diodes, and there's one important point that I'll point out over here is the Zener diode, which is acting as a voltage regulator. So basically, the battery that we're using is a 12-volt battery, and in this case, the battery cannot provide the 12 volt to the Arduino Nano, because if it does that, it would destroy the Arduino. So the Zener diode is acting as a voltage regulator, so the Arduino can see the 5 volt coming into the Arduino.
Here we decided to use the Arduino to charge both lithium-ion as well as the lead acid battery. As you can see, the lead acid battery charged slower than the lithium-ion battery because it has a higher internal resistance. So therefore, it took only 7 hours as opposed to 5, like the lithium-ion. Here we are analyzing the different qualities of a 3-cell nickel cadmium battery. And we use the lithium ion battery from previous experiments to power the relay because both relays are acting as our charging and discharging for the batteries. We also use the 3.6 nickel cadmium battery in series, and as you see from the graph here, it shows that it only took an hour and 30 minutes to fully charge.
Well, I'm a teacher. I work in Spring High School, in Spring ISD. So from this battery project, I get some experience, and I believe if we can implement that in our school, the student will be benefited. And how I'm going to implement that? The student will learn how to use multimeters to take the voltage and current measurement, and then student will conduct a series and parallel circuit using batteries and resistors, and a lesson plan has been implemented to conduct a hands-on experience in the classroom setting. The lesson will be implemented in a traditional classroom setting where a student will be inspired by the hands-on experience so that they can relate to their real-life situation.
Okay, this is our conclusion. Lithium-ion and lead-acid battery may be used for energy storage for solar power, and this designed Arduino hardware and software system for charging and discharging batteries. And also we obtained the charging and discharging of characteristics of those 3 different batteries, which are lead-acid, nickel-cadmium, and lithium-ion.
In the future, we would like to analyze the capabilities of the different batteries by observing their charging density. For me personally, I would like to conduct the same experiment but with different microcontrollers such as Raspberry Pi PIC and my home institute of Kennesaw State University, Hugo Alves, and my professor would be Dr. Bill During, working alongside me.